Hey everybody, in this video I'm going to spend some time going over some formula writing for coordination compounds. And in this case, this is question 23.36 in the 13th edition of Brown-Lemay-Burston. So let's get to it. I think the only way that you can really, the only way that you're really going to excel at this is if you practice. So I'm going to take this and I'm going to kind of start backwards. That's kind of where I go. So perchlorate is the ClO4 minus ion, and that's going to be what we use to counterbalance whatever this tetraaquodibromomanganese 3 ion is. So this can change, but this is an ion that we should have gotten from a different like you should know what the perchlorate ion is. Okay, sometimes it'll be chlorine, sometimes it'll be bromine. In this case, it's perchlorate, but it has a 1 minus charge. Okay, and so now we're going to continue to work backwards for the other half of the molecule, and now here's manganese 3. So I'm going to, manganese has the symbol Mn. Oh, let me write that in a more reasonable spot. Okay, so Mn, manganese. Okay, and now we go to the front and we're like tetraaquo, or tetraaqua. So aqua is what we call water when it's in there. So there's 4 of those things. And dibromo is Br2. And notice when we use parentheses and when we don't. Here we use parentheses because there's more than one atom part of that ligand that's on the metal. Here we just have, for this one, we just have the 1 atom, so that's bromine, and so we can just put the 2 without any parentheses. Okay, so let me take this thing and move this, not spin it, let's take and move this thing over here. Okay, and now this guy goes into brackets. This is the complex ion. Okay, but now we need to know what the charge on this thing is. Okay, well, this is where knowing oxidation numbers helps us. So this thing is the 3 plus, because that's what it says right here. That's the 3. This is 0, and each bromine is a minus, so that's 2 minus. So this is a 1 plus overall charge. So that means we really just need one of these in order to make this neutral. So if I'm writing this out as my answer, it's going to be Mn parenthesis H2O and parenthesis 4 Br2 end bracket ClO4 minus. Okay? Okay, let's do another one. Let's do part B. Okay? So now here's this funny thing it says bis. Okay, and then it says bipyridyl cadmium 2 chloride. Okay, so again, I think that one of the skills that you should have is you should be able to split this and know that chloride is the negative part of this, and that's what we could have 1, 2, 3. We're going to be able to figure out how many of those we have based on the charge of the complex ion. Okay, so we're kind of working backwards through the whole thing. Okay, so now this guy is cadmium 2, so we're going to write that here. Again, it's going to be in brackets, so cadmium is Cd, and then back bis bipyridyl. Okay, so here's the thing. Some of these ligands have names that we can abbreviate, like ethylene diamine, we can abbreviate EN. EDTA is already abbreviated, but that's ethylene diamine tetra. It's so commonly abbreviated that I even forgot what it is. Okay, so this guy we abbreviate BIPY. Okay, so this is going to be BYPY. Okay, we call it BIPY. Okay. And how many of those do we have? We have 2. So remember, the prefix bis is used if the ligand already uses one of the original prefixes. So that's BIPY, and then so that's our So that's what we have, but now we need to figure out the charge. It turns out that Bp is a compound. Okay, so this is just a 0 charge. Cadmium is 2 plus because we have this 2 plus. So the overall charge on this is 2 plus. So that means that if we're going to worry about this chlorine, that means that we're going to have 2 of these chlorines so that the overall charge here is 2 minus. The 2 plus and the 2 minus cancel each other out. So that makes this written out nice and clean. Right, makes it CD Bpy, Bypy 2 and bracket Cl2. Okay, so that's pretty cool. So now the next one. Okay. Potassium tetrabromo orthophenanthroline cobaltate 2. Okay, so this is good. So we should be able again to split this, and so we have K, which is positively charged, and we can have as many of those as we need in order to cancel out whatever this is, whatever that charge is going to be. So we're going to again start from the metal. We will put this in brackets and we'll do cobalt, CO, because cobaltate, remember when the metal is part of the negative side of this thing, we put the 8 ending on it. Okay. And then it says tetrabromo, so Br. We don't need, so we have, and then we have bromo 4 because it's tetrabromo, and then orthophenanthroline. Okay, again, this is one of those that you can just abbreviate as OPhen. Okay, OPhen, and then that gets bracket at the end. Now, what do we have to do? We have to try to figure out what the charge on this is. So cobalt is 3 plus from the name. Each bromine is 1 minus. So if each bromine is 1 minus, that means that this is 4 minus total. So an orthophenanthroline is neutral. So that means the overall charge on this is -1. So now how many potassiums do we need to cancel out the -1? Well, we just need 1. So the formula on this is K bracket CO Br4. I almost put a parenthesis there. And then a parenthesis for the OPhen and bracket. Okay, so now the next one. Cesium diamine tetracyanochromate 3. Okay, so again, we should know to separate this. Cesium is a 1 plus charge. Okay, so that we are going to add as many as we need to counteract whatever the charge on this ion is. Okay, so now this is the complex ion. We put Cr here because that's chromate. And remember, this is the charge or the oxidation state of that ion, so, or of that metal. So that'll come into play in a minute. And now we look at the parts to it. Tetracyano, okay, CN4, and then diamine. So amine is the ammonia, is the way we write ammonia, and it's diamine. Okay, so now we figure out what the charge is. This is 3. This is 1, sorry, this is 3 plus. This is 1 minus. Each of them is 1 minus, so there's 4 of them, so that's 4 minus. This is 0, so 3 plus 4 minus and 0 is a 1 minus charge. And then cesium is a 1 plus charge. So we have CS, we only need 1 of each of these to cancel each other out. Bracket CR, CN4, sorry, make sure that that's a CN4. Parenthesis NH3 and parenthesis 2 square bracket. Okay, and even though we list these in alphabetical order in the name, they don't have to be listed in order in the formula. Okay, so it doesn't matter which order those two go in. Okay, so now the next one, tris ethylene diamine rhodium 3 tris oxalato cobaltate 2. So this is now two complex ions. So again, we should be able to split it here, and then remember we need the same. We need to make sure that the charge on this side equals the charge on this side. This is the positive side. This is the negative side. We know it's negative because of cobaltate. So let's go backwards. So we're going to do this side, CO, and then it says tris oxalato. Okay, so again, oxalato is one of those that we can just write OX for. We can abbreviate. And then this is 3. Okay, and now what's the charge on this guy? Well, cobaltate is 3 plus. Each oxalato is 2 minus, so that makes this a total of 6 minus. So the overall charge on this is going to be 3 minus. Okay, so now we do the same thing for the first molecule, okay, or the first half of the molecule, the first ion. Okay, we're going to start backwards at rhodium. So we have rhodium RH, and then tris ethylene diamine. So again, ethylene diamine can be abbreviated with EN, and there's 3 of them, so there's that. And now ethylene diamine, if we're trying to figure out charge, has no charge. Rhodium in this case has a 3 plus charge, so this is going to be 3 plus. Okay, so now look, this 3 plus is equal to that, well, equal to in magnitude, but opposite direction. So those two cancel out. You only need one of each. So the formula for this is going to be bracket RH, parenthesis EN for ethylene diamine, 3, and then end bracket. Now start new bracket, CO, and then oxalato, OX, 3, with close bracket. Okay, so that's naming. That's coming up with the formula based on the name, and hope this helps. Have a great day.